Today we're going to look at an infinite geometric series. It's a geometric series like we were just looking at, but it's infinite, meaning it goes on forever and ever. An infinite geometric series has no last term. However, some infinite geometric series still have a sum even though they go on and are listed forever. Others do not. Here's an infinite geometric series. Well, we're going to look at our sums. S sub 1 is the sum of the first term. Well, that's just 8. S sub 2 is the sum of the first two terms. That is 4 and 8 for 12. S sub 3 is the sum of the first three terms. Well, we add that together and we get 14. Then we go and add the first four terms, S sub 4, and we would get 15. Go S sub 5 and we would get 15 and a half. Then the next term, if we did S sub 6, we would get 15 and then 3/4. And then continuing to add, we get 15 and 7/8. Now you notice each time we keep adding more and more terms, we're going up and getting larger and larger. However, we're not going up and adding as much each and every time. So this one does have a sum. However, let's take a look at this one here. S sub 1 is 1/3. S sub 2, sum of the first three. That's 1 and 1/3. S sub 4, or 3, be the sum of the first ones here, which would be 4 and 1/3. S sub 4, it would be the sum of the first four terms. Now, here we were increasing as we kept adding. Here you'll notice we're increasing as we keep adding. But here we weren't increasing by as much each time. Here we're increasing by more and more each time. When you keep adding more and more larger and larger numbers, there's going to be no sum. This one over here would have a sum. Well, what determines whether you have a sum or don't have a sum is your ratio. If r is between 1 and -1, you actually have a sum. Let's look back here. Here, our ratio was 1/2. It was between 1 and -1, so it does have a sum. Here, you're multiplying by 3. It's not between 1 and -1, so there is no sum, and we saw that as we tried to work it out. Here's your formula for finding the sum of an infinite geometric series. It's just your first term over 1 minus your ratio. So, we want to go ahead and find our sums here. Well, the first thing you need to do is to go ahead and find r, because it's r that determines whether it has a sum or not. If r is between 1 and -1, it has a sum. Remember, to find r, you would take your second term, -3/2, over your first term. Or you could take your third term, 3/4, over your second term. And in this case, no matter which ones you do here, you end up getting the same one of -1/2. -1/2 is between 1 and -1, so we should be able to find our sum. So we're going to take our first term then for our formula, plug it in, over 1 minus our r, which is -1/2. And then we're going to take the top, divide it by, and then put the whole bottom in parentheses. We end up with 2. Then we'll take a look at this one here. It's an infinite geometric. It's going on forever. It's geometric because here you can see we're multiplying by 2 each time. But we're going to say there is no sum since r is not between 1 and -1. Over here on the far right, this is an infinite geometric. It's going on forever. You'll notice you're multiplying by 1/2 each time. 1/2 is between 1 and -1, so there is a sum. So we can use our formula up here in the upper left corner. We can go ahead and plug in 1 over 1 minus your ratio, which once again was 1/2. So you get 1 over 1/2, which ends up being 2. So let's go ahead and find this one here. This is an infinite series. We know it's an infinite series because we're adding because of the e, and it's going to infinity. Since this part right in here fits this right here, which is for our infinite, for our geometric series, we know then that our first term matches up with this here, and that has to be our 5. Therefore, what the exponent is on has to be your ratio, and well, that has to be your 1/2. So we have an infinite geometric series with your first term being 5, your ratio being 1/2. Since your ratio being 1/2 is between 1 and -1, we can find our sum. Once again, to find your sum, you do your first term over 1 minus your ratio of 1/2. On the bottom simplifies down to 1/2. You get 5 divided by 1/2, which is 10. Infinite geometric series can help us when we're dealing with repeating decimals. We're going to work this one out in a couple different ways. 0.25 repeating is really a 0.25, followed by a 0.0025, followed by a 0.000025, and so on. Notice these two, the 2,5 here would take the place of these 2 zeros. The 2,5 and the 2,5 here would take the place of these 4 zeros, so it does end up being 0.25, 25, 25, so on. But you notice this is an infinite geometric series. Your first term is a 0.25. Your ratio here, when you take the second term over the first term, is 1/100th, or 0.01. So then you're going to get 0.25 divided by 0.99, which ends up being 25 over 99. That's one way to do it. A second way you could do it is you could go ahead and say, well, n equals your original number. Now, since you have 2 decimals being repeated here, we're going to multiply both sides of this equation by 100, because we have 2 decimals and 100 has 2 zeros. So if you had 3 decimals being repeated, you'd multiply both sides by 1,000, because that has 3 zeros. Multiply your n by 100, multiply this by 100, and remember that's going to, when you multiply by 100, it moves your decimal point over 2 spots, so you get 25.25, 25, 25. Now what we're going to do is we're going to subtract this one here from the top one. On the left side, 100n minus 1n. The right side, all this repeating stuff is identical top and bottom, and that's going to drop out, so you get your 25 minus 0 here. So then you still divide and get 25 over 99. So what is 0.9 repeating? This one here we're going to actually look at in a couple different ways. 0.9 repeating, you should know, is 0.3 repeating, plus 0.3 repeating, plus 0.3 repeating. Most of you recognize that 0.3 repeating here is really just a third. This 0.3 repeating is a third. This 0.3 repeating is a third. And a third plus a third plus a third is 3/3, which is 1. Or we could look at it like we did in the last slide with the idea of a geometric series going on forever, an infinite one. A 0.9 repeating is a 0.9 plus a 0.09 plus a 0.009 plus a 0.0009, and so on. So since it's an infinite geometric series, we could take our first term, a 0.9, divided by 1 minus your ratio. When you take your second term over your first term, or your third term over your second term, you get 1/10, or 0.1. So then you get 0.9 on the top over 0.9 on the bottom, which is 1. You could also look at it like we did on the last way in the last slide, where you let n represent your number. You have one number being repeated, so let's multiply this side by 10 and multiply this side by 10. Multiplying by 10 on the right side moves your decimal point over one spot. Then we're going to go ahead and subtract. Subtract the left side, subtract the right side. On the left side, 10n minus 1n is 9n. On the right side, all the repeating stuff drops, and then you get 9 minus 0. Divide both sides by 9 to get n by itself, and once again you get 1. So 0.9 repeating is 1.